Solution of linear system of equations in 3 variables. Here in the given linear system, we are given 3 equations in 3 variables. We will use elimination method to solve this system and find the values for x, y, and z, which are in fact intersection of all the 3 given lines. So let's get started, and we divide this problem into 2 groups. Group 1 will consist of equation 1 and 2. So this would become 4x minus y minus 2z is equal to 0, and the second equation would be 2x minus 3y plus 3z equal to 9. This is group 1 of equations consisting of equation 1 and 2, and in group 2 we will have the equation 2 and 3. So this will be 2x minus 3y plus 3z equal to 9. That is equation 1 for this group, and the second equation for this group would be minus 6x plus 2y plus z equal to 0. So for group 1 this is equation 1, and for group 2 this is equation 2. Similarly for group 2, here we have this equation as equation 1, and this is equation 2 of the second group. Now what we will do in group 1 and group 2 simultaneously, we will eliminate x from equation 1 and 2 in group 1, and also we will eliminate x from equation 1 and 2 of group 2. So for eliminating x, what we do is we have adopted a standard procedure for 2-dimensional straight lines. So, and in that what we do is we write coefficient of x for both equations. Coefficient of x, what is for equation 1, that is 4, and what is coefficient of x for equation 2, that is 2, and then we write down the equations. What is 4x minus y minus 2z equal to 0, and here we have the second equation, 2x minus 3y plus 3z equal to 9, and we in fact cross multiply these numbers, like coefficient of x for equation 1 will be multiplied with equation 2, and coefficient of x in equation 2 would be multiplied with equation 1, so that we have equal coefficients of x. So this system will reduce to 4x minus y minus 2z equal to 0, and this whole equation is multiplied by 2, and the equation 2 is multiplied by 4, and this is 2x minus 3y plus 3z equal to 9, and both of these, equation 1 and equation 2, will become 8x minus 2y minus 4z equal to 0, and the second equation will become 8x minus 12y plus 12z is equal to 36. And just like we have done in the past, what we do is we do a subtraction for eliminating x, And what happens during this process is we change the signs of the lower equation, that is plus, this will become minus, this will become minus. X will get eliminated, leaving behind plus 10y minus 16 z is equal to minus 36. And now we can see that 2 is common throughout. So what we can do, we can divide the entire equation by 2 in order to reduce the size of its coefficients. So this equation becomes 5y minus 8z is equal to minus 18. And let's name this as equation A. So this is equation A, what we have achieved from equation 1 and 2 of the given system by eliminating x. X is gone, and now we will do the same thing for group 2. And the group 2 equations are, for group 2, what are the equations for elimination? The equation for elimination are 5y minus 8z. Group 2 consists of 2x minus 3y, 2x minus 3y plus 3z. 2x minus 3y plus 3z is equal to 9. And the next equation, equation number 3, is minus 6x plus 2y plus z is equal to 0. Plus z equal to 0. So for group 2, this is equation 1 now, and this is equation 2. We can write, and we adopt the same procedure for elimination. Coefficient of x here, coefficient of x, that is 2, and coefficient of x, which is minus 6 here, and we will multiply these coefficients. So minus 6 will multiply with equation 1, and this 2 will multiply with equation 2. So that's what we do here. Minus 6 times 2x minus 3y plus 3z is equal to 9. And the second equation will become 2 times minus 6x plus 2y plus z is equal to 0. So this is our system of equations called equation 1 and equation 2. And once we multiply, this will become minus 12x plus 18 y minus 18 z equal to minus 54. And the second equation, minus 12x plus 4y plus 2z is equal to 0. So these are the equation 1 and equation 2 again, and they have the same meanings as the given equations in group 2, because the multiplication of a constant number on both sides doesn't change anything. And now for elimination of x, we subtraction, and for this subtraction we are going to change the signs, and this will become plus, this will become minus, minus, and minus. So x will be eliminated, leaving behind 14y and minus 20, z equal to minus 54. And if we divide throughout by 2, as 2 is common throughout, what we will have is 7y minus 10z is equal to minus 27. And let's name this as equation B. So what we have achieved from the given system of linear equations, we have eliminated x from equation 1 and 2, as well as eliminated x from equation 2 and 3, resulting in two equations in two variables. And what are those equations? Those equations are, now the system is reduced to two equations in y and z. And what are those equations? The equations are 5y minus 8z equal to minus 18 as equation A, and the equation B is 7y minus 10z is equal to minus 27. And now we will solve equation A and B for y and z by elimination method. We use elimination method to solve A and B for y and z. And for that, what we do is we again take coefficient of y, on, and we write again coefficient of y. And what is coefficient of y in A? That is 5. And what is coefficient of y in B? That is 7. And what we are going to do, we are going to write both those equations, 5y minus 8z equal to minus 18, and 7y minus 10z is equal to minus 27, and then multiply this with equation A and multiply 5 with equation B, so that the resulting equation have equal coefficients for y. So 7 times 5y minus 8z equal to minus 18, and 5 times 7y minus 10z equal to minus 27. So this is still equation A, and this is still equation B. Now the actual multiplication what will give us is 35y minus 56z equal to minus 18 times 7, that will give us minus 126, and the second will give us 35y minus 50, z equal to minus 135. That will give us minus 135. So now when we subtract, we use the standard procedure, subtraction for elimination. And what we do here, we change the signs of second, minus, plus, and this will become plus. So y gets eliminated, giving us minus 6z. Minus 6z is equal to minus 126 plus 135 will become 9. So z is equal to minus 6 over minus 6. We divide both sides by minus 6 to eliminate the coefficient on left hand side. So this gives us value for z. Z is equal to minus 3 over 2. This is value for z. We have got the value for one variable, and now what we will be doing again is writing the equation a and b, and this time what we will do is we will eliminate z. So coefficient of z and coefficient of z in equation a and equation b, and these are minus 8 and minus 10, minus 8 and minus 10, and we are going to rewrite the equations here. 5y minus 8z equal to minus 18, and 7y minus 10z equal to minus 27, and we'll do the same thing again. We'll multiply coefficient of z in equation 2 with equation a, and coefficient of z in equation 1 will be multiplied with equation b. So this cross multiplication and this cross multiplication, this will give us minus 8 times 5y minus 8z equal to minus 18. So this is minus 10. In fact, this is minus 10. That will be multiplied minus 10, and here what we will multiply is minus 8 times 7y minus 10 z equal to minus 27. So that is still equation a, and this is b. And this is going to result in the equations minus 50 y plus 80 z is equal to 180, and the second will become minus 56 y plus 80 z is equal to 27 times 8 will become 216 and 16. So now we are going to eliminate z, and for that purpose we are going to subtract again. Subtract, and for that we are going to change the sign, and here this will become z will be eliminated, and this will give us 6y equal to minus 36, and that will give us y equal to minus 36 over 6. This will give us y is equal to minus 6. So y is equal to minus 6. We have already found the value for z. Now we have got the value for y as well. Both of these values for y and z we are going to substitute in equation 1 of the given system. Substituting y is equal to minus 6 and z is equal to minus 3 over 2 in equation 1 of the given system. What we will get is the value for x. What was the given system was 4x minus y minus 2z. 4x minus y minus 2z. 4x minus y minus 2z equal to 0. So when we substitute these values for y and z, this will give us 4x minus, instead of y, what are we going to substitute as minus 6, and minus 2 instead of z is minus 3 by 2, minus 3 over 2 equal to 0. So 4x plus 6, and this will become plus 3 because 2 will be cancelled with this 2 equal to 0. So this will give us 4x plus 9 equal to 0, and what will be given to us is 4x equal to minus 9 and x equal to minus 9 over 4. So we got the value for x as well. We have got all the values for x, y and z. So the point minus 9 over 4, minus 6 and minus 3 over 2 lies at intersection of lines in the given system. But if we want to verify this, we can definitely verify this as well. For that purpose, verification. For the verification process, what we are going to do, we are going to divide our space in 3 sections, and we will write all the 3 equations side by side. The first equation is 4x minus y minus 2z, 4x minus y minus 2z equal to 0, and the second is 2x minus 3, 2x minus 3y plus 3z equal to 9, and the third is minus 6x plus 2y plus z equal to 0, and we will be replacing x, y, z in all 3 equations with the values. This will give us 4 times minus 9 over 4 minus y is minus 6 minus 2 and z is minus 3 over 2, and this should be equal to 0 if this point in fact lies on the line. This is 4 gets cancelled with 4, leaving behind minus 9 plus 6 and plus 3 here equal to 0. This is minus 9 plus 9 equal to 0. So 0 is equal to 0. So this is verified that the point lies on line 1. Let's similarly find out for second line. Minus 9 over 4 minus 3 times minus 6 plus 3 times minus 3 over 2, and this should actually be 9. So this is 2 times 2 here, that's minus 9 over 2 plus 9 and minus 9 over 2 equal to 9, and this in fact is 9 minus 9 equal this is 2 times minus 9 over 4 minus 3 times minus 6 plus 3 times minus 3 over 2. So this should be minus 9 over 2 and plus 18. This is plus 18 here. So plus 18. This is plus 18 minus 9. Oh, this is minus 9 over 2 minus 9 over 2 equal to 9. So this is plus 18 here. So 18 minus 9 equal to 9, and this gives 9 equal to 9. And the third one, that is minus 6 into x is minus 9 over 4 plus 2 into minus 6 minus 3 over 2. This should be equal to 0. So this is minus 2 and 3. This should get equal to 27 over 2. So this is 27 over 2 minus 12 and minus 3 over 2 equal to 0. And this is 27 over 2 minus 24 over 2 minus 3 over 2 equal to 0, and this is minus 20 plus 27 over 2 minus 27 over 2 equal to 0. So this will be cancelled, 0 equal to 0. This is verified, this is verified. Therefore we conclude that so the point is minus 9 over 4, point minus 9 over 4 minus 6 minus 3 over 2 lies at intersection of given lines in 1, 2 and 3.